Hey everyone, happy Wednesday. This is Mr. Russell here to talk to you guys about negative exponents. Hope you all had a fantastic Memorial Day weekend this past weekend. Hope you all did well on the lesson yesterday. If you didn't, if you have any questions, please guys, don't hesitate to reach out to one of your teachers. We're always here to help you. They want to help navigate and help you with exponents as much as we can. We're coming down on the home stretch here. We don't have too much time left, okay? So today we're going to move into like one of the last things we really got to talk about when it comes to exponents. And that's, what if we have a negative exponent? Okay, it's something we've been trying to avoid so far. We want to show you how we approach a situation like this. Okay, so I'm going to start with this example here, which is x to the third divided by x to the seventh. And I'm going to show you guys how we can simplify this three different ways. Okay, so the first one would be, what if I expand out each power as much as we possibly can? Meaning x to the third, we can write that as x times x. That didn't work out the way I thought it would. Times x, right? And on the bottom, we have x to the seventh, which is x times x times x times x times x times x times x, right? So at 3x on top, 7x's on the bottom. And then we can simplify the ones that we can cancel out because we know anything divided by itself is 1. So we have first x divided by x would be 1. That cancels out. X divided by x is 1 again. X divided by x is 1 more time. Okay, so I kind of cancel out all the x's in my numerator, which would mean up top, we're left with just 1. That's all we're left with there. On the bottom, we still have x times x times x times x, which is x times itself 4 times, which we can write as x to the fourth. Okay, so we kind of, in this case, look at it as we had more x's in my denominator when I started, right? We had 7 down here. So it makes sense that we should be left with more x's in my denominator as well. Okay, so that's one way we can kind of look at that. So the second way would be to look at kind of what Miss H showed you guys last week, okay, when you have the quotient rule, okay? So I could write this as, all right, well, up top, we have x to the third. At the bottom, x to the seventh, we can kind of break that apart and think of that as x to the third times x to the fourth. Because we know if I was to re-simplify this, x to the third times x to the fourth, I'm multiplying powers with the same base, I would add them up, so 3 plus 4 is 7. I just kind of like undid that there. And then I have x to the third divided by x to the third, so like before, those cancel out, right? So again, I'm left with, all right, my x's all canceled out up top, so we're left with just 1. On the bottom, you see we're left with x to the fourth. So both those methods, guys, you see how this simplifies to give us 1 over x to the fourth. Now I want to think about the way Mr. Colangelo talked about an example like this yesterday. And that was with the quotient rule, which says to subtract the exponents. Now, if I do that here and I subtract what's happening here, I have x to the third over x to the seventh, right? So I can, using the quotient rule, write that as x to the third minus 7, right? Subtract them in that order. But what's 3 minus 7? Negative 4. So that means this would become x to the negative fourth. And we have an issue because I want you guys to try to reason that out, right? X to the negative fourth means x times itself negative 4 times. How can you multiply something by itself a negative number of times? You can't. That just doesn't make sense. And this is where our issue is. So here's what we're going to do, folks. When we have a situation like this where we have a negative exponent, I want you to look at what it actually simplified to when we expanded it out and simplified. Because that's how we fix negative exponents. If I have x to the negative fourth, we're going to rewrite that and fix it by instead writing it as 1 over x to the fourth. Do you guys see that? Or to write it a little more clearly, if I had x to the negative fourth, that equals 1 over x to the fourth. It's kind of like if an exponent is negative, we fix it by taking that power and moving it to the other part of the fraction, right? Because right now, I could write that over 1. So we kind of took this power from my numerator and fixed it by bringing it into my denominator. That's kind of like a trick way. So you guys see that? So that's the main idea here, right? Simplify to that. So x to the negative fourth would mean 1 over x to the fourth. And then what if our exponent was negative in our denominator? What if I started as 1 over a to the negative fourth? Okay, so I want you to think back to yesterday, and we talked a lot about 1. What kind of powers ended up simplifying to 1? Well, it was anything raised to a power of 0. So really this 1 here, I could think of that as a raised to a power of 0, right? Isn't that the same thing, right? Because anything raised to a power of 0 is 1. I kind of like unsimplified that. Now think about this using the quotient rule. I am dividing powers at the same base, so we can subtract the exponents, which means I would write this as a, well, up top we have 0 minus negative 4, right? I'm subtracting this negative 4. And guys, what happens when we subtract a negative? Oh, that becomes addition. So what's really 0 plus 4? A to just the fourth. So now look at that one. All right, we just looked at when I have a negative exponent in the bottom part of a fraction, it fixes, or we simplify it, by moving that power into my numerator. Isn't that cool? It kind of always flips like that. And that's a big thing I want you guys to write in your notebook for me, okay? So negative power rule says that for every non-zero number a and integer n, a to the negative n equals 1 over a to the n. What I also want you guys to write down is that kind of the opposite of that. If I had 1 over a to the negative n, sorry my pen's squeaky, is going to equal a to the n. But the whole thing is look at that pattern, right? If it's negative in my numerator, because I can think of that as over 1, I want to simplify it by moving it or flipping it into my denominator. If it's negative in the denominator, we take it, we flip it, and now it's positive in the numerator. And that is our negative power rule. Make it the example you want. Let's say my example was x to the negative fifth, right? That would simplify to 1 over x to the fifth. Let's say, make a big example, maybe you want to do the opposite of that. You want to say, no, wrong button. 1 over y to the negative fourth. Well, that would then simplify to just y to the fourth. Okay, let's do a couple examples. So, first one, we have 5 times a to the third times b to the negative second. You notice I said times in between all those? Because these things are all being multiplied together. So it's 5 times a to the third times b to the negative second. So one of the big things is that we always have to simplify negative exponents. So you notice how in this example, I didn't initially tell you what I want you to simplify, but when you see a negative exponent, you got to tell yourself, oh, that doesn't make sense. We have to fix that. Okay, so the 5 is okay. The a to the third is okay. It's that b to the negative second that we need to fix. So if you want to, I'm going to kind of really break down these steps here. I could write that as, well, my 5 is fine. It doesn't have a negative exponent. The a to the third doesn't have a negative exponent. That's fine too. And that b to the negative second power here, this is what we have to fix. Remember, think back to what we just said. If it's b to the negative second, I would fix it by writing as 1 over b to the second. Let's write that. So I can write that as times 1 over b squared. I'm going to flip that thing over. But I don't want to just leave it like that because all these other things are all over 1. So let's multiply them all together. What do we have in our numerators right now? We have 5 times a to the third times 1. So that's just going to be 5 a to the third. What do we have in our denominators? Well, we have 1 times b squared. So I'm just left with b squared. And that's how that would simplify. You notice I just took this term here, I just kind of brought it into the denominator. Next one, 1 over x to the negative fifth. I think I just accidentally used this as an example, but it's negative in the denominator, so I'm going to write it as just x to the fifth. Okay? If you need to, guys, pause this video right now and make sure you have these examples in your notebook. Okay, if you're good, let's go on to the next page. These ones you don't have to have in your notebook. I just want you to kind of watch how I kind of change these things around. So you notice how each example here, think of these as 3 different fractions. I have this example, I have my second example, and my third one. What I want to do is identify the parts that we need to fix, and we're going to move them into the parts of the fraction that would give us positive exponents. So this first one here, I notice I have an a to the negative 5th, so that has a negative exponent in my numerator. I would fix that by bringing that one into my denominator. Oh, isn't that cool? I love this slide. Okay, oh, I have this y to the negative 2nd. That's a negative exponent. So we'd simplify it by bringing it into my numerator. Okay, and we also have this z to the negative 1st. Let's bring that into my numerator as well. And then my preference, guys, is when I have multiple variables, I want to write them in alphabetical order. So I'm just going to kind of switch these around. So b squared, y squared, c, and then time over a to the 5th z squared. Now look at no more negative exponents. So that one is simplified. We're good. Next one. Now I want to show you guys a very common mistake I see. We have a negative 5. What's the exponent on that term? Because yeah, I know the 5 is negative, but it still has a positive exponent. Because if I brought it into the denominator, now I have a negative 1. That would be an issue. We don't want to move any negative numbers. We just want to move any numbers that have a negative exponent. And you see that over here. We have 3 raised to the negative 1st. So let's bring that term into my denominator. You know, see how it fixes that? Okay. And then, all right, I have nothing else negative in my numerator. My denominator, we have d to the negative 5th. Let's bring that term into my numerator. Okay. And I'm just going to arrange them. Let's get them in alphabetical order. Awesome. Sometimes what I tell my students, guys, is a trick to remember is the fraction bar kind of acts like a filter. And when you take that power and pass it through the fraction bar, it filters out that negative. Just another way to think of it. Okay. Now, next one. Okay, I want to simplify this one. All right, so I have all positive exponents in my numerator, so we're good. But both terms or both pieces in my denominator have negative exponents, so we got to fix those. I mean, so both powers, I should say. Okay, so let's move them both to my numerator. And I'm going to put them in alphabetical order. There we go. Okay, so now we have all the positive exponents. There we go. Excellent. Okay, now we're going to do a couple more examples. This will be our last slide here. And these ones you should be putting in your notebook. If you want to wait till the end, that's totally fine. Okay. First one, we have 2 times x to the negative 3rd. Again, we're multiplying 2 times x to the negative 3rd. So the problem with that is just this x to the negative 3rd. My 2 still has an exponent of 1. Okay, so it still has that positive exponent. So my 2 is going to stay where it is. It's just this x to the negative 3rd that I need to move. Okay, so think of this whole thing as over 1. And let's move the power of the negative exponent into my denominator. So that would simplify to 2 over x to the 3rd. Okay, second one. All right, what's the problem with the second one? Well, I noticed that I have a y to the negative 2nd. I want to fix that so it's negative in my numerator. Let's bring that into my denominator. So that would simplify to x squared was fine. It had a positive exponent over 6y squared. Okay, third one. What's the problem with that? Oh, well, I have a negative exponent in my denominator. So I want to fix it. Wow, this pen is very squeaky on this screen. Let's bring that into my numerator. So that means that would simplify to just 3x to the 4th. Okay, number 4 over here. Well, first I see, ooh, negative. I got an exponent of 0. That's going to simplify to just 1. So that'll kind of, in a way, just cancel out. Now, what else do I notice? Well, I have a y to the negative 2nd. I want to fix that. So that has to go into my denominator. And we have a z to the negative 3rd. So that has to go into my numerator, right? So now when I simplify that, we're going to get, well, the 4 is going to stay put. The z to the negative 3rd, this piece is going to move up into my numerator. So now we have z to the 3rd. over on the bottom, I still have my 5 down there, and then y squared. Okay, and our last one, we have 5x squared over negative 2 to the negative first. So the issue with that is this negative exponent in my denominator, this negative 2 to negative first. So that has to move up. So now simplified to my 5x squared was fine where it was. And times, now I brought that negative 2 up top. Now, since we have these two numbers here, we want to multiply those together. What's 5 times negative 2? Oh, negative 10. So negative 10x squared. Okay? So guys, that's how we approach negative exponents. If it's a negative exponent in my numerator, let's bring that power into our denominator. If it's a negative exponent in the denominator, let's move it into our numerator. Okay? So make sure you guys have these examples right in your notebook. Your lesson check for today is just to take a picture of the notes you took and upload that to the Google form. If you need to go back and complete your notes, please use that video to go back and forth. But if not, we will talk to you guys tomorrow. Have a good one.